New and innovative, high-strength, long-lasting PVD coatings. That's the topic today of our presentation in the Virtual Technical Forum from the World Money Fair 2022. Unfortunately, we are still in the pandemic. Let's hope it will be finalized soon. My name is Romain Waidelich. I am CEO of INORCOAT, owner of the company, a company which is dedicated to the production of PVD coating equipments, PVD coating cathodes, and also PVD coatings itself.
Welcome. My name is Martin Andritschky. I'm teaching material science at the University of Minho in Portugal. And since 35 years, I'm working on PVD coatings and the transfer of the PVD coatings into reliable industrial processes.
Our agenda today is, first of all, to start with a comparison of galvanic chrome plating, which is still in some of our industries a conventional plating technology, versus PVD chrome plating, which is already widely known. And the next step is to give you the view of INORCOAT, a holistic approach of chromium-free coatings, considering not only the coating process, but also the decoating process. Then we will speak about the latest developments from INORCOAT together with Professor Martin Andritschky about our new multi-layer coatings, which we named CircuCoat. And after that, we will briefly introduce you our new coating equipment, the MS700, very compact device to produce and apply the coatings on striking dies. So let's start with a very short introduction to the topic. So especially here with a comparison galvanic chrome plating versus widely known PVD chrome plating. So what are the problems with galvanic chrome plating? It's a chemical process. We have issues with carcinogenic fumes which are produced during the process. We have problem with hexavalent chromium, chrom-6. These substances are quite harmful for humans and are globally complicated to handle. The second step is where you are coating. It could be that you have also decoating. Decoating is similar to a standard galvanic process. You are using some chemicals and you have the same fumes which can exist like during the coating process.
PVD coatings, which means coatings which are deposited in vacuum, are generally used in the form of chromium or chromium alloy ceramics. This chromium deposition occurs in vacuum without any use of hexavalent chromium and is therefore environmentally okay. Nevertheless, we coat also the substrate holder, we coat other machine parts, and those machine parts need to be decoated from time to time. And during the decoating process, if it's chemical decoating process, there might occur, just as described before, the hexavalent chromium. Therefore, since PVD coating is a very versatile technique, we develop chromium-free coatings.
So we have a more holistic approach. So we are thinking not only in the coating process, but also the decoating process, as Martin has already mentioned. He was mentioning decoating of shields, but sometimes we also have to decoat the dies, repolish them, rework them, recoat them, and use them again for the striking. And to be able to do it in a holistic way, we developed a group of coating which is based on chromium-free elements and produced in our machines. Martin will give us a more detailed introduction in this new development.
The basis of the PVD coatings are ceramics. Ceramics are hard, ceramics are brittle. So the hardness of the ceramics is typically 4 times the hardness of hardened steel. What we do is we introduce into these hard ceramics soft metal phases. We introduce them in the form of nanocrystals or in the form of nanolayers into the ceramic coating. And these metal phases, these soft metal phases, stop the cracks immediately after starting. And this turns the whole coating very tough. And they not only stop the cracks when they start, they also provide that the cracks do not propagate until the substrate and propagate into the substrate, and therefore the coating also protects the substrate.
So what have we done? As I mentioned, we developed together with Professor Martin Andritschky this new group of coatings. As you can see on this slide, we have developed 3 variants, which are all based on the same elements. On the one hand, CircuCoat high speed. So high speed, high S means for circulation coins application, where you have a high speed of striking, where strong elasticity of the coating is needed. The second one, as mentioned, based on the same elements, is CircuCoat N. N stands for numismatic. This is a coating which has been adapted for soft blanking materials like gold and silver. And the last one is CircuCoat MM. CircuCoat MM has been developed for multi-material, so bicolor blanks, which have different materials in the coin, like, for example, plastic substrates or a standard B metal blanks, which we know from the €1 and €2 coin. The specificity of our coating is that they are all based on the same elements, but all coating recipe has some specific characterization independent of what we want to strike, which give us a very high flexibility and which also helps us to find the optimal coating solution for the dependent blank material which we want to strike. The next step is, as I mentioned in the beginning, we will speak about how to produce these coatings, because for this you need a machine, and we decided to develop a new machine specifically for the minting industry. This is the new compact MS700. The challenges which we could understand in accordance to the industry is that a compact footprint is needed, all-in-one design, plug and play, simple to install, fastly to turn up, user-friendly, highly customizable, flexible tool holder so that we are able to coat different die sizes in one batch, and also to be able to coat other tools which are used in the minting industry. Then to have a flexibility in regarding of the production of coatings. So this means that we had incorporated multiple cathodes. The specific point is we are producing the cathodes ourselves. They have been patented. And also the possibility to integrate linear ion sources as an option when special cleaning options are needed. Our machines are produced in a way that they are not only for coating dies, but we can also coat coins, make decorative coatings, etc. Let's have a closer look of the machine. As you can see, the machine is divided in 4 segments. We have under segment number 1 the vacuum chamber, where the coating process is actually happening. Under 2, we have the vacuum hydraulics. With vacuum hydraulics, I mean we have the pumping system to achieve the vacuum which is necessary to apply a PVD coating. Under 3, we have the space where the process gases are integrated into the vacuum chamber. Independent of local regulations, we can place the gas bottle for the processes there, so we avoid special piping work inside the building where the machine has to be installed. And finally, under 4, we have the electrical cabinet. We are quite proud that we have been able to put all elements which are necessary to have a very high flexible machine inside a very small cabinet, electrical cabinet. So here is the machine, as you can see in the picture. I think it is also in the back of me. This is a MS700 machine. It has a compact footprint size 1.6 meter by 1.6 meter with an age of 2.2 meters. All is integrated, electrics, gas system, etc. It is fully automatized based on Siemens SCADA system, assuring a high, easy to operate HMI.
If the computer control and the HMI could be considered the brain of the machine, then the cathode, or what we call the magnetrons, are the heart of the machine. The atoms are liberated from the magnetrons and directed also by the magnetic field of the magnetrons towards the substrate. And like this, we guarantee that on the substrate the ceramic is formed with the metal inclusions. Additionally, in PVD coating, you need to activate the surface prior to the deposition to guarantee a good adhesion. This is done both by plasma cleaning in situ, or optionally, if the more profound cleaning is needed, by a linear ion source.
As I mentioned, the high flexibility, we spoke about the brain, about the heart, but we have to also have the part holder where we put the substrate is a very flexible unit. We can interchange the tool holders, we can mix all kinds of sizes of dies on one holder so that we can easily coat different sizes in one batch. Coming to the brain, our HMI is, the machine is fully automatized. We are integrating the cooling chiller, so we are assuring a safe operation of the machine, especially for the devices which are incorporated. It is easy to operate, start, stop. I'm always mentioning the aspect that the machine is never lying to you, because we are always recording all parameters which need to be recorded in our HMI, where we can see live on trends what is actually happening in the machine. All this information is integrated batch-wise in the history of the machine, which can be exported, for example, to Excel. Another aspect is that we have a power management of the machine, so it is easily calculable how much power is used to apply one coating, thing which is quite important nowadays when we are thinking of environment, when we are thinking of resource saving approach. The machine is ready for the future. What means ready for the future? It means that it is an open interface. The customer can himself, or with the help of us, or with other technological partners, continue the development of the coating, change the parameters of the coating, independent how his product is changing, for example, new blank material, etc. And this makes the machine not a machine ready for the present, but fit for the future, which is quite also our sustainable approach in total.
Thank you very much for your attendance, and if there are any doubts, please contact us.
Thank you.